So we'll have a slight change of pace now. We have Pradeep talking about the role of FOSS in assessing the state of India's birds. Pradeep is a wildlife biologist working on applied ecological and conservation science issues in the Indian context.
Good morning. So just before I start, a quick show of hands. How many of you watch birds for fun or as a hobby? Great. That's a lot of us. I was just wondering, even as of this morning, how I'll introduce this talk, because this is about very different things compared to what we've heard about this morning. This is not about anything that you could do a pip install birds with. A friend of mine at breakfast told me if I said that, people will know what I'm not talking about today. This is about birds that we see around us, lots of them. India is lucky to have over 1,000 species of birds to be found here. So, at State of India's Birds is a partnership of many individuals and 14 different organizations. We've all come together to assess the state of India's birds, right? So, what we set out to do is provide the best current knowledge on the status and conservation of India's birds. We do that by curating, analyzing, and synthesizing available information and producing a variety of knowledge products that are used by a wide variety of folks in various walks of life in the country. All the knowledge products we produce are freely available, and all our science and results are published publicly and freely. The main flagship knowledge product we produce is a comprehensive report that we call the State of India's Birds reports. There have been 2 editions so far. The first one was in 2020. The most recent one was in 2023. So perhaps the most central thing, the key thing that we rely on to build our work on, is a large corpus of publicly available citizen science data. So birders, like many of you here, who are, I'm guessing many of you are familiar with the eBird platform. eBird is a corpus of data where birders submit their logs of birding activity, observations of birds, and so on. In India, as you can see in the GIF there, somewhere around 2013, 2014, activity on eBird in India picked up, and it's just gone through the roof in the last year. There are nearly 60,000 people on the platform now, logging 3.8 million hours of birding. There are upwards of 70 million observations on the platform. 700,000, more than 700,000 locations these logs are submitted from, and this covers 1,379 species of birds across the country. Yeah, so that's the massive growth of observations, the data corpus that we can build on. So at the partnership, we all got together and tried to work with it to see what sense we can make of about the status and trends of birds. But the one thing about eBird data or many citizen science data like that is it's often opportunistic hobbyist birders and hobbyist citizen scientists submitting observations. So when scientists come to apply rigorous statistical approaches and frameworks and methods to completely unstructured data like that, you have to be a little bit careful in dealing with the data and making sure it's properly cleaned and so on. And then the statistical modeling approaches can be applied. So all of this is plenty of processing and analysis, statistical analysis. So what we do is we build all our analysis on R. We use many very powerful, what we found as being very powerful statistical and data processing libraries in R. For example, the entire tidyverse universe for data cleaning, statistical modeling using LME4 and unmarked, and parallelization and visualization also using R packages. So that's just a schematic of the processing involved. So we start from the eBird data, but after some processing, there are 2 different branches. Each one branch produces the trends of how the abundance of birds as they are observed out there, and also the other branch produces a distribution range map for each species. So for each species, we are able to produce these trends and distributions. And then both those are put together along with a bunch of other metadata, so to speak, that are known about birds in India. And we put all of this together and come up with what we think is the conservation status for each species. So that's and all of this scientific work, whether it is methods or results, they're all public. All the code is public. It's archived in a archiving platform, Zenodo. Our GitHub account has all the code involved. All the results also, like I said, for every species we're able to produce the trends and distribution. So there we have a website where all of that is available for easy consumption. If you I don't know if you can see my mouse, but this little card there is what a page for a particular species looks like. So the distribution range map for all of India, the trends over many years, starting from before 2000 to now, that time series, and all the associated information. And that's the website. If you ever want to go take a look, you're most welcome. In addition to just that website, we also have a web tool which we call Mina. Mina stands for Monitor Your Neighborhood Avifauna, thanks to ChatGPT. But also, I mean, it's really good because it's also a very common and very widely loved bird that we see out there everywhere. So this is a web tool where you can use this tool to build on the data corpus that we start from eBird data. We do some pre-processing and cleaning and so on, and make it a little bit more tight and rigorous. And on that corpus of several tens of millions of rows of observations, this web tool is built. And using this, you can build localized regional reports on the broad picture of bird life in that area. So, for example, species details, IUCN status, seasonality, most common species, endemic species, all of these things. And even, I mean, we already have heard about these reports being used by many advocacy groups, many people in the forest department, many places where citizen groups want to go, advocate for a particular patch of some natural area being protected or some planning around there and so on. So these reports are used to give a summary of what bird life is there in those areas. So this is so the SOIB, what State of India's Birds does is captured in this schematic, where essentially we start from we stand on the shoulders of work that bird watchers put in by going out there and observing and logging their observations onto this eBird portal. eBird, generously, the terms of all the data is once you upload it in there, the entire corpus is public. So we are able to benefit from the entire corpus of nearly 100 million rows of data for India. We use that to come up with the State of India's Birds, the analysis for each and every species. We have from 1,300 and odd species. After doing statistical analysis and seeing how well the statistics works out and so on, more than 900 species we have trends and distribution ranges for in that website. So 940 or something, if I remember right. So that comes out of the State of India's Birds. Then we have the Mina tool through which you can build regional reports. And using that, hopefully people are using this out there and they see that them contributing to eBird is going around and coming back to them being able to use it to understand more about the regional bird life and so on. That's where State of India's Bird sees itself. One of the key challenges at a purely practical level has been that the data corpus, like I said, has been growing very fast in the past decade. When we made our first report in 2020, the corpus was 10 million rows. All the analysis for nearly 1,000 species ran on my friend, one colleague, his one laptop, took care of all the analysis. When we got to 2023, that corpus had grown to 30 million rows of data. Already, the compute resources we had across the partnership was creaking a little bit, and then it's just been really hard as the data corpus has been growing. Now we are sitting on more than 70 million rows of data, and in a couple of years, if we want to do another report, we may be looking at nearly 100 million rows of observations to deal with. So just the computation, just to get all of this analysis through and get the results, is something that we were not used to. And then some of us, we learned. I mean, we all had FOSS and all of these things in the back of our mind, but then we realized that's essential, that we simply don't have the skills to be able to do this ourselves. So we now speak to folks like you in the room. Some of you have been generous and very kind, and you've come along and helped us. And now we are actually within striking distance of being able to do this analysis, not just now, but into the future as well. Even, we are future ready. We will be able to do this analysis, even if it crosses 100 millions and so on. It's highly scalable. So the scalability and affordability of this kind of an analysis to enable work of State of India's birds is just central. All of us are non-profit organizations, government institutions in the partnership. We are not software people. We know some science. We are ecologists. We know some conservation science. But people like you are really crucial in order to be able to help us do what we do. So thanks a lot for all the FOSS work that you all do. Some of it does come around. And so, yeah, the takeaway is FOSS is key even to enable work that even folks like us do. Thanks a lot.